Okay, we're continuing with worksheet 2, reviewing over 7.1 and 7.2. Calculate the area of the shaded region. We have two curves here, the 2x squared minus 6. Way we can tell the difference without having to use our calculator or having to graph it. You see that 2x squared, that's a positive x squared, so we know it's going to resemble a parabola opening up. And then the 10 minus 2x squared, we know it's a parabola, but the negative 2x squared indicates it must be a parabola that opens down. So therefore we know the 2x squared minus 6 must be this curve that's opening up, and the 10 minus 2x squared must be the curve that's opening down. We set the two equations equal to each other. We bring everything over to one side, factor out the 4, continue factoring difference of squares. We get 2 and negative 2. So then our area formula is just top minus bottom. Top is on the 10 minus 2x squared. The bottom is at the 2x squared minus 6. Careful that you protect the bottom function with a set of parentheses since we're subtracting that has to distribute through. So we have our top portion minus our bottom portion. Our bounds from negative 2 to 2. Expand this out, plug in the calculator, or work this out by hand, and we get 128 over 3. There's no pi involved since there's no rotation going on. We're just finding area, no volume with disk or washer yet. All right, number 7, same shaded region, but now we're rotating about the line y equals 10. So y equals 10 is going to skim the surface of this graph, but there's going to be this whole gap that we have to account for. So any sort of a gap or hole, we have to make sure we draw 2 radius because we need to do a washer method. So we extend from our axis of revolution to the furthest boundary. That's going to be 10 minus parentheses 2x squared minus 6, and then little radius 10 minus the curve that is closer, being the 10 minus 2x squared. We protect all these with a set of parentheses so we don't forget to distribute the negative through. So distribute through, combine like terms. So then we have big radius quantity squared minus little radius quantity squared from negative 2 to 2. Enter in our calculator and then attach the pi to our answer. All right, number 8, we have y equals x cubed minus 1. We have y equals 7, x equals 0, and then we're going to do top minus bottom here. Top is at the 7, the bottom is at the x cubed minus 1, and again we set that, label this with the parentheses so we don't forget to distribute through. Top graph minus bottom graph. And also, yes, we have to find our intersections, so we set the y equals x cubed minus 1 equal to 7, and when we solve for x, we get x cubed equals 8, x equals 2. So our right bound is 2, and we can tell the left bound is going to be this vertical line at 0, so from 0 to 2. Enter in our calculator, we get 12 square units. All right, number 9, same shaded region as before, but notice that our axis of revolution is at 8. So because of that, the fact that there's now this gap between this dotted line and the shaded region, so we have to draw 2 radius, one that extends from the axis to the boundary, to the further boundary, and then one that extends from the axis to the closer boundary. So big R is the one that's longer. So we do 7 minus parentheses x cubed minus 1. And then top minus bottom here. Top is at the 8, the bottom is at the 7, so 8 minus 7 is 1. Big radius squared minus little radius squared. From 0 to 2, our bounds carry over from the previous problem. So 744 over 7 pi cubic units. All right, 10 and 11 both refer to the same shaded region. Let's discover that. So y equals square root of x. That's this radical function here. X equals 0, it's a vertical line. Y equals 3, that's a horizontal line here. So there's our shaded region. We do top minus bottom, but let's first find our intersection. So we set the root x equal to y equals 3. root x equal to 3, we square both sides, solve for x, we get x equals 9, our left bound is 0, and then we do top minus bottom. Top of my rectangle here is at the 3, the bottom is at the root x, so 3 minus root x, use power rule, or plug in the calculator, we get 9 square units. All right, number 11, same shaded region, but we're rotating around an axis. So we look at the location of that axis. It's up against the flat surface of our shaded region. So all we need is one radius. We should need to rely on this method here. Okay, so we do top minus bottom. We draw a radius that extends from the dotted line to the boundary of our shaded region. Then we do top minus bottom, 3 minus root x. Bound is carryover from previous problem from 0 to 9. So big radius squared. We can either work this out, power rule, distribute, or plug in the calculator. Integral from 0 to 9 gives us 13.5, and then we just add pi to our answer, or 27 over 2 pi cubic units.